Hi my friends, I decided to make some sheet parts models because some of you, my friends, asked me to do this. You remember we already modeled this part, which was modeled in my tutorial number 034, and now let's try to create this model, which has this drawing with all the dimensions. We start by using the template sheet metal millimeters, and we consider the drawing. First element which I want to draw is this face, 36 on 80, with a contour here and some holes. First, the contour is important, so let's start with the plane XY, where we draw a rectangle with dimensions 80 tab 36 home. We place the midpoint in the origin, and we use some of our known techniques. For instance, to draw an arc after a line, you have to look at the tutorial number 007 at the minute 3:48. Dimensions: this is radius 6, the distance from the center is 16. We apply split for this point and this point. Why? To make this construction line, and then we can apply fillet radius 6 to this corner and this corner. Finish sketch, F6. Now we want to create a first volume. To create a first volume, we use the tool face, but we have to apply a certain thickness. Here we don't have possibilities to apply that certain thickness, so we use sheet metal defaults. By the way, the thickness is here, 2.5. Yes, so that we disable this option, use thickness from rule, which was 0.5 millimeters, to apply 2.5 millimeters. Okay, but where is the rule? You can ask me, where is the rule? Well, if you use tools and not tools, manage, and you go to styles editor, but I place this to quick access toolbar to have it here. Yes, we have this tool on the toolbar, so we activate the styles editor. We don't use lights, but we go to sheet metal rule, default. The default sheet metal rule is in inch, as you see, by default. So we go to default millimeters, and here we have 0.5. If we want, we change here the thickness, but let's use this way. Sheet metal defaults with 2.5 to be our default thickness. We use the tool face and we have the first volume. Good. Next is this flange. Yes, this is a flange. We create this flange, which has dimensions 28 from the base and 860 dimensions on horizontal, by using the tool flange. We select the line of bending. This is the line of bending, and some options here, like offset. Offsets are left and right, yes, this dimension and this dimension, which are 5 millimeters. We have the 8 millimeters, and in the other end we have to place an expression 80 minus 8 minus 60. Yes, I mentioned these dimensions in the drawing. Good. And what about the solution here? Is this the right solution? No, it isn't. We want to have the bend starting from here, the end of actual line we selected. So we place it here. Good. And what is this dimension? This dimension is 28 from the base. So we place here 28. The measure is from the base. Okay. I want to present this from this angle, so I click on the corner and I make this. Let me show you. I make this set current view as home, fit to view. Yes. And now you know, if I click on home or F6, we have this presentation. You have to notice that small cut to be able to create the bend. Then we use the corner round here of 6 millimeter, which is by default now. Okay, F6. Now I want to verify the position of this cut, and I go to the face and I see that there is not a pin mark here, so it means that this is not fully constrained. Double click and we see here 3 dimensions needed. A lot of dimensions were forgotten, missed. They were missed. Let's see which dimensions. Apply. some are here. Yes, the position on horizontal of this cut. Remove, done, and we place the dimension in the drawing, which is 24. Dimension from the circle to the face, 24. And we still have here some bad dimensions. Why? Because we placed this point, which was the midpoint, but now I have to reconsider. I apply on the same vertical this point on this point and coincident the point with the line, because now the middle was loosed. Okay, now we have fully constrained. We use a parametric software, so we can change everything anytime by modifying parameters. Parameters are here, you know this. Yes, a lot of them are by default, because we use sheet metal template, which has some options already placed here. You can study this to be familiar with the sheet metal defaults. Okay, and now the holes. Here we have 1, 2, 3, 4 holes. One of them is placed in the same center with the fillet, and the other are with dimension 6 and the line of 16, 20, 14 on 26. Diameter is 5. Let's apply this on the face, on the bottom face. 1, 2, 3, and this is not necessary to be marked because there is a mark here. 6 is here. Same horizontal of the point with the center point of the cut. 20, 14, and here is 26. Yes, another one. Dimension is needed. Yes, I know. These two are not on the same horizontal. Let's apply same horizontal for this. Now we have fully constrained. Don't forget this point. Hole of 5 where the small crosses were placed, but also here. Okay, 5 millimeters. On this face there are 3 holes of 4 millimeters. One is at the center of the flange and the others are on the centers of fillets. Remember 14. Face. Only one point we place here, same vertical with the midpoint of the flange, and dimension from this bottom face of 22, not 22, 14. Good, don't forget this too. We apply hole 4 millimeters and this small cross and these 2 points. Okay, that's the part. We select material, which is aluminum. I select this and this is the part. Let's verify if the volume is this. Part 3, right click, I properties, physical, update. You see the value, I copy it and I place it near this value to see if we are okay or not. Text here, paste, okay, and you see the identity. It can be not the same, but here is because it was a very simple part. I have to make a mention. You see in the drawing there are some dimensions here, 2.5, 1.25, and we didn't verify this one. We placed 36 at the beginning and we don't know if this is 41. I know that the thickness is 2.5 and the distance from here to here is 2.5 because you see radius 5 is by the rule, is a value given by the rule. Let's measure the part. We rotate it to see better, and M from Monaco is the tool measure. We see that this is 5 millimeters. Click here and we see that the distance is 41. We measure also the dimensions from this face to this line, 2.5. We measure the distance from this face to this line is 1.25, like in the drawing. You see, you have to know this when you create a part, to know what are the radius, what are the default cuts, and they are taken from the rule. You see, this is the rule. You have here about the bend, thickness multiplied by 0.5, half of thickness is the relief depth, and the minimum remnant, which are these dimensions. You have to be familiar with all these elements. When you create a corner, it has dimensions also from the rule. We'll make more than this one part, so I don't want to mention this in the future. Yes, that's all for today. Thanks for watching. Bye bye.